All right, here we are, Unit 3, Lesson 2. Lesson 2, there we go. So yesterday, or the unit before this, or lesson before this, we talked about, systems of equations, right? So when we have two things on a graph and we're looking for where they intersect, right? They're two intersection points. Or sometimes solutions simply just mean x-intercepts, right? So 1 and 2. So we talked about them graphically, okay? Now, today we're going to talk about them using algebra to solve, okay? So graphically is like a visual thing. Algebra is using the steps, and we're actually going to be looking at complex systems today. So not just two linear or a linear or quadratic. We're actually going to get a little further, a little deeper than that. But first, let's talk about some graphs that we don't know about yet, right? So we have a few graphs in our toolbox already, right? We definitely have linear graphs, right? Where y equals 2x minus 1 when the equation has just a single x there, right? They call this a degree of 1 because there's one x. And then equations like this where y equals x squared, we call this a second degree. And the reason we call it a second degree is because there's two x's here. Now, we're also going to introduce these two types of graphs right here, this one and this one. These two top graphs are called polynomials, nomial graphs. These two are not. These are not polynomial graphs, okay? This first one is called a rational function. Rational function. I know it's a rational function because one, it creates this double split line on a graph, and 2, the equation has x in the denominator of a fraction. Yes, I said fraction, don't freak out. Okay, we're dealing with fractions. This other new graph that we're going to talk about is called a square root function. Okay, a square root function. I know it's a square root function because it does this one, like it's almost like a half of a quadratic turned to the side, right? Half of a quadratic turned to the side. I also know that it will always have one of these symbols in it. This symbol right here is called a radical. Okay, radical. Just for knowledge, radical. A lot of times we say square root, but it's actually called a radical symbol, and you could actually have cube roots, fourth roots, fifth roots, and so forth. We'll only be dealing with square roots though, so we're fine. So these are our two new types of graphs, okay? And today we're going to deal with these two new types of graphs, and we're going to impose other graphs on it, like a line, right? So now we have a linear system with a rational system, and we're looking for these 2 points where they meet. Or we might have a square root with a line, right? Where we have this point where it meets. So let's get into this algebraically though, okay? Because graphically, I think by now you know, if I graph two things, I can look where they intersect here and there. But algebraic gets a little bit hard. So let's talk a rational function. So let's go with 4, and these probably won't come out to nice even numbers because I'm just making them up off the top of my head. 4 minus 6x equals 10. Okay, just going off the top of my head. All right, right away you've already freaked out because you're like, Miss, it has a fraction in it and I don't know how to do it. Well, remember that if fractions have like denominators, right, denominator, then I can just simply do whatever operation is there. This is a denominator and this is a denominator. If there's x in the problem and there's another x, they're the same x, okay? They don't have different values in the same problem. They may have different values in different problems, but not in the same problem, okay? So here I'm just going to take 4 minus 6, and I got negative 2 over x equals 10, okay? Now, my goal is to I want to get rid of the fraction now, right? So to get rid of this x, I'm just going to multiply this side by x and this side by x. And if I multiply this, right, x divided by x is 1, and 1 times negative 2, therefore it's just negative 2. And then I have now 10x, okay? All right, and now what I'm going to do is I'm going to divide this one by 10, and I'm going to divide this one by 10. Okay, and I'm going to go ahead, negative 2 divided by 10. We can just leave that in fraction form, it's fine. equals x. Okay, so here's my solution, right? So I have negative 2 divided by 10 equals x. So I only have one solution to this problem. Sometimes you might have two solutions, right? Because if this looks like this, and I have a line going through it, I could have two, but I also could have one, right? So in this problem, what I have here is on this side, I have some type of rational equation. But on this side, I only have a straight line. 10 is a straight line. So if I were to split these up and put them on a graph to check my answer, right? I put y equals 10 on one line, and then I put y equals 4 over x minus 6 over x on another line, and I would check to see if they intersect at negative 210. But this is only an x value. How do I figure out my y value? Well, in this case, my y would be 10 because that's a singular entry over here, okay? So I could say it would be intersecting at the point negative 2 over 10, comma 10. Now let's look at a point where I will have more than one solution, okay? So let's take this, let's go 5 over x minus 3 over x equals x minus 4. All right, now, once again, what I want to do is I want to go ahead and just simplify this side first, right? Because these are fractions. They have like denominators. So I'm going to do 5 minus 3, and I have 2 over x now equals x minus 4. Now, in order to get rid of this x here, I'm going to multiply this side by x, right? But I'm also going to multiply this side by x. And notice that I just put parentheses. It's because I need to multiply each of these different terms by x, not just one. I want to make sure they both get it. So let's start over here. X divided by x is 1, and 1 times 2 is simply 2, right? And then over here, I'm going to go ahead and use my rainbow. X times x is x squared. And x times negative 4 is minus 4x. All right, you might have recognized what I have going on here. Maybe you don't recognize what I have going on here. What I have going on here is a quadratic equation. I know it's a quadratic because of this little guy right here. What kind of quadratic equation? Is it standard? Is it vertex? Is it factored? Well, right now it's none of them. However, if I move this 2 to the end over here and make this 0, then I have a standard, right? So now I have 0. We're just going to subtract, okay? Equals x squared minus 4x minus 2. Perfect. Okay, first thing I want to look at, can I factor this? Is there two numbers that multiply to negative 2 and add to negative 4? I already know in my deep down heart the answer is no. There's no way to have two numbers to multiply to get a smaller number that add to a bigger number other than one more than itself, okay? So this is not possible, so I can't factor. But we have another thing in our back pocket that we can use on quadratics, and you used it in Tomko's class, and it is called the quadratic formula. So let's bring that bad boy back over here on this next slide. So we have an equation 0 equals x squared minus 4x minus 2. Okay? Remember, my a, b, and c do not include the x. Okay, the equation isn't a squared, it's ax squared, where a and x are two different things. So in this case, a is invisible or a ninja 1, b is negative 4, and c is negative 2. So here's our formula. This is negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Okay, so I'm going to start substituting in here. Okay, this is really not a hard thing to do. A negative is a positive 4 plus or minus the square root of negative 4. I gave it parentheses because if you don't give this parentheses, it's going to come out to a negative number when it should clearly be positive, okay? Minus 4 times 1 times negative 2. Bam. All right, all divided by 4, all divided by 2 times a, which is 1. All right, cool. When I do these, you guys, I really just try to put this whole part, everything under the radical symbol, this part in my calculator, not including the radical symbol. Okay, this is called the discriminant. Okay, it tells you how many roots you're going to have. If this number comes out as positive, then you have 2 roots. If it comes out negative, you have no roots. And if it comes out 0, you have 1 root. Okay. So first I'm going to put just this part in my calculator. So I'm going to do a negative 4 squared minus 4 times 1 times negative 2. So right here I got negative 8, and right here I got 16. So 16 minus 8 is 8. All right, now so I have 4 plus or minus the square root of 8 divided by 2 times 1 is 2. Okay, remember that this isn't one problem though. This is actually 2 problems, right? Plus or minus. Have you seen a plus or minus in your calculator? Because I sure haven't. Okay, plus or minus here. All right, so in that case, I'm going to have to split this up into 2 problems. Let's do my positive version over here. 4 plus the square root of 8 divided by 2, and my negative version, let's do blue, and that's 4 minus the square root of 8 divided by 2. All right, I could simplify this more. I truly, truly could. But honestly, this will be a hot mess of a number, okay? This will be a hot mess of a number. Why will it be a hot mess of a number? Because it's going to be a long irrational decimal that I don't want to deal with. So I'm going to just leave it just like this. It's fine. If you have a perfect square right here, the perfect square is any two numbers that multiply by itself to get a number, so like 1, 4, 9, 16, 25, 36, then go ahead and do the operation. But if you don't, 8 is not a perfect square. So let's not do that, okay? So let's leave them alone. But now this is only my x coordinate, right? This is my x's, my 2 x's. I'm going to have 2 solutions. So let's go back here really quick. Apparently I skipped one. And let's look how I can find my y. Well, if I just use this side of the equation and substitute my x back in here, I can find my y really easy. So let's say I put that in for, I got 4 minus the square root of 8 divided by 2 minus 2. Also a hot mess, so you know what? Let's leave it. So now that means I'm going to have, this is my y, right? So my x will be 4 minus square root of 8 over 2, comma, 4 minus the square root of 8 over 2 minus 2. This is my coordinate. I promise it's my coordinate, okay? And also the other version, right? I have the negative version, but I also need the positive version. So I'm going to have the minus or the plus version. The minus or the plus version, okay? So this just denotes 2 of them. And that's really going to be it for today. Okay, it's all you're going to do. There are some other ones on here. If you want to stay and keep watching because you want a refresher, that's fine. If not, you can go do your work. But if you want a refresher, you can stay right here. And the refresher is going to be simple. You're going to have equations that are x squared equals 4. Okay. To solve this, just take the square root of this side and this side. Remember, when we take a square root, we have a plus or minus version. So x will equal either 2 or negative 2. And remember, this is just a singular number on this side, so your y is 4. So I got negative 2 comma 4 or 2 comma 4. And that one's a simple, easier one. Another one that you might see on their thing is going to be one that's just a little more complicated than that one, and it would be like x squared plus 5. I said 5 row time. Plus 5 equals 14. Okay, just one more step than the one before, and that's just minusing the 5 here. Sorry, minus 5. So now I have x squared equals 9. Same, back to the same process. Square root here, square root here. This is plus or minus 3. And then this one is x equals, okay? So now I have 3 comma my singular number 14. Had this been had an x, I'd have to substitute back in, but since it doesn't, I don't need to, okay? And there we go. There's our 2 solutions. And that's it. That's really all you're doing today.